Good morning. This webinar is brought to you as part of the IRIS e-learning series and discusses the 10 main advantages of polymer infrared windows over crystal infrared windows. Number 1. Crystal infrared windows are both hygroscopic and fragile. This means that their primary failure modes are either through impact or by the absorption of water, acid or alkalis commonly found in industrial environments today. Polymer windows were built specifically to design out these failure modes, and IRIS was the first company in the world to develop its patented industrial grade IR window systems. As you can see in this impact test, the IRIS polymer infrared window systems are super tough. You can take a 5-pound sledgehammer and repeatedly beat it and it has no effect on the system whatsoever. Point number 2. Polymer infrared windows have an unparalleled field of view because we're not limited to the size restrictions of crystal infrared windows. Because of their fragility, crystal infrared windows are not really seen in diameters much larger than 4 inches, where polymer infrared windows, the IRIS polymer systems, are available in all shapes and sizes. The following animation is designed to show just how versatile the IRIS wide format infrared windows are. This comparison is between the IRIS Cap 12 window and their standard 4-inch window. In this you can clearly see by manipulation of the camera through the viewing angle, obviously the Cap 12 has almost twice the height and 4-5 times the width of a standard 4-inch window. So utilizing that extremes, we can see a lot more through a Cap 12 than we can a 4-inch window. In fact, up to 12 times more depending on the depth of the cabinet. But looking at a standard depth of cabinet of 12 inches, looking through this 4-inch window now, you can see my limitations are pretty tight, and if I do want to see all of the connections in here, I would actually have to utilize multiple windows, where using a single cap window I can see everything I need to see. So to see what I can see through a Cap 12, at 12 inches, it would require 4 4-inch windows to see the same thing. Therefore showing just the benefits of large format infrared windows. You use a lot less windows and the costs are cheaper. So point number 3, fixed and stable transmission. Polymers are unaffected by the hygroscopic failures that we see in crystal windows. They're a stable lens, they are non-hygroscopic, and obviously because of the mechanical strength of the units, we just don't have the same failure points. This is a video that shows an experiment that we did just to show the clarity of vision through each of the windows, because one of the things we get asked about is, obviously looking through the grill, does it affect the image, etc. So this was a test that was done using a FLIR E60, which is a 320 by 240 array camera, 10 inches away from a known heat source, with using our IRID high emissivity target labels on a shiny surface, in this case stainless steel. The emissivity of the labels is 0.95, so we set that on the camera. So looking at this video, we can clearly see that in the top left hand corner the measured temperature is about 119 degrees Fahrenheit. Now the first window I put in front, as you can see, is a crystal infrared window, and as you can also see the writing is clear, we can see that, and there was a temperature drop. Now utilizing the same experiment, we took one of our opaque VPFR lenses, which is, you can't see through with the eye, but you can clearly see the infrared image. And we repeated that same experiment with the clear polymer VPT, which gives you the visual inspection as well as infrared and ultraviolet. Now when we compare the results of that experiment, you can clearly see the VPFC, which is a calcium fluoride crystal infrared window, showed a 33% loss, compared with a VPFR opaque polymer lens window showed a 23% loss, and the VPT IR window clear polymer lens showed a 22% loss. So you can clearly we can clearly use all 3 types of lens, but the benefit of using polymer lenses is they're unaffected by the hygroscopic and mechanical failures that are seen in all crystal lenses. and we have what we call a fixed and stable transmission. This transmission will never change, and that is what is more important to the thermographer, that this transmission doesn't change, and they're going to get good, solid, reliable results for the life of the installation. Now, point number 4, any camera, any task. Polymer infrared windows are an infrared transmissive lens. They can be used by infrared, visual and ultraviolet cameras. Our PolyView IR system, which is our clear polymer system, was developed approximately 3 years ago and really is a global leader in the science of infrared window and electrical maintenance safety device technology. Here we have an example of some Fluke and FLIR cameras utilizing the VP system windows, and the image quality is fine and their customers are very happy with the performance. Number 5, arc containment tested. There is a myth about arc resistant windows. This is a myth. We do test infrared windows continuously with OEMs in their systems to define their arc containment properties. Now, what we did at Iris was we came up with a test that was required on metal clad switchgear, which is a much tougher test. So I have a video here showing the test that was conducted on our EMV systems. We had multiple windows in here. This test was conducted to the IEC 62271-200, which is 1 kV to 50 kV metal enclosed switchgear. Now, it was a 6.5 kV, 31.5 kA test. The pressures that we've seen in there were for 18 bar. The test period was 1.1 second, and actually the peak current of the test was 83 kVA. So it's a very, very tough test, and our new EMV systems were designed to beat that. So point number 6, certifications. Iris has the most certified infrared window systems in the world today. Yet we have certified to every requirement of CSA, UL, NEMA, CE, IEEE, DMV, Lloyd's, ABS. In fact, we are the most certified marine application window in the world. So again, Iris takes its testing and certification very seriously, and we have stressed our products to the limit. Anti-fogging, point number 7. Crystal infrared windows obviously have more mass than we see in polymer infrared windows, which are thinner. So what happens is, on cold or warm and humid days, we tend to get a lot of humidity build up on the crystal lenses because they have a lot more thermal mass. And we have to wait for them to equalize and clear before we can use them, which in some cases may take several hours, and you may turn up to do a job and you can't do the job because the windows are all fogged up. Polymers, because of their have a much less thermal mass, are clear virtually immediately. So again, crystal infrared windows do fog, and polymers are unaffected by this humidity fogging. So again, one of the main disadvantages of using polymer windows is the fact that they are anti-fogging. Point number 8, customizable and innovative. As I said earlier in this presentation, most crystal infrared windows are limited to about 4 inches in diameter. In fact, what Iris calls a 4-inch diameter window, that's the viewing diameter. Other companies, they say it's a 4-inch window, but the actual viewing diameter might only be 3.5 inches. And some of them increase their thicknesses because we know they're thinner. The thinner windows have less strength, and when they increase their thicknesses, it does affect the transmission rates. So they're limited to a 4-inch window, but Iris, obviously, because of our patented industrial grade lens systems, we're the first company in the marketplace today to come out again with larger format windows, because obviously with our systems and our innovations, we are not limited to the size restrictions that crystals enforce on our competition. So we now build windows specifically to meet our customers' requirements. In fact, what we say is, why should you fit a round window when Iris can make a window fit you? You know, we can make windows that make sure that you can get what you need when you need it in the best possible way. Here are some examples of different windows that we've made, ultrasound ports, in fact, and a new system, the Quick Fit IR, which is a spacer plate modification in the bottom right hand that you will see entering the marketplace in 2016. Point number 9 is that polymers are far more affordable than crystal infrared windows doing the same job. And by that I mean, if we look at this slide here, what I'm showing now is a piece of switchgear that has 12 round 4-inch infrared windows that are installed in this switch. They're about $500 each, and with the installation charges of approximately $100 a window, the customer spent nearly $7,000 on the supply and install for this panel. Iris does it like this. We actually make large format infrared windows that go over the plexiglass or Lexan viewing windows that are in switchgear. That way, you can still do your lockout tagout requirements through the clear polymer, but you don't have to cut another hole. We make a window to fit that hole. The window in the bottom of this is a CAP CT24 standard window, which is about $800 retail in the United States. So this whole job, $1,400 for the custom window installed, $1,000 for the lower window installed, was $2,500. So it's significantly lower cost, approximately 40% of the cost. We have 300% of the functionality because these windows can see a lot more. As we've seen earlier in this presentation, we're very limited by field of view, and that's why they put so many of these round windows in, because of the internal cables and barriers that limited what they could see inside the panel using small or 4-inch round infrared windows. So we can do a lot more with a lot less using large format polymer infrared windows. Point number 10 is Iris's lifetime warranty. Iris has an unconditional lifetime warranty on all of our polymer products. And we, that compared to the warranties of our competition, which are limited to, in the majority of cases, to manufacturing defects only. They leave out the material defects because they know that crystals will fail. So their warranties are limited to manufacturing defects only, and actually do not cover the material which we know fails, which is a crystal infrared window lens. So in summary, crystal infrared optics are totally unsuitable for industrial applications due to their fragility and hygroscopic nature. Crystal infrared windows are unsuitable for customizable industrial applications due to their poor mechanical strength and the cost that will be associated by trying to make these larger format windows. Polymer infrared windows were designed specifically to overcome the traditional failure modes of crystal infrared windows. And Iris has the most unique and robust infrared window solutions and EMSD products available in today's market, primarily because of our patented reinforced polymer lens technology. So thank you very much for taking the time to listen to this presentation. If you'd like more information on this and anything else to do with our other electrical maintenance safety device products, please visit www.iris.com.